If you're just coming in on the video, we are solving each equation for x. So I want you to take a second and solve each equation for x. I bet as you're working hard to get this thing solved, I bet Miss Bennett can make a guess on which one you're working hard on. I bet to the left you solved that equation no problems, right? You're like, this is easy, right? But then when you went to the right, you had a little bit of trouble. Are we right or are we wrong? Or am I right or wrong? What do you think? Give me some feedback, face to facers. And I'm right. Okay. What about the other face to facers or e-learners and face to facers? What am I right, e-learner? Wait, I'm confused. Face to facers, am I right? Yeah, okay. E-learners, I heard of one right. What about the rest of you? Okay, some people saw, they didn't know if it's right. Hey, what did you get for the first one, guys, when you solved this? X equals what? X equals 9. I agree. Okay, you got x equals 4, 9. Okay, let's look at this. Remember, we'll use our inverse property. So I'm going to get rid of the subtraction first by adding 5 to both sides, right? And when I do that, I end up with the 5's canceling, and then I got 2x equals 18. 2x equals 18. The next step I do, again, are inverse operations. If I'm multiplying by 2, that means that I'm going to do the inverse of that. I'll divide both sides by 2. So x equals 18 divided by 2, which is 9. And I honestly, oh, you typed in the wrong number. Okay, gotcha. Yeah, because I was thinking the same. But then, okay, now I understand. All right, so I honestly believe everybody in here has no problem solving for x, just from what I see. So let's talk about this other side, and then we'll discuss what literal equations are. This other side says solve the equation for x. Now, the only difference with literal equations and actual equations is that literal equations just have a ton of variables. See, on this side, we got numbers in there, so we're happy about that. We like that. But over here, we got letters in there. That's not cool. We don't like that. But I'm trying to tell you that literal equations are a lot easier literally. I promise you, as long as you know your inverse operation. Okay? And the reason why literally, I see what you're saying, Tia, I do. Okay? So the reason why literally this is easier is because since I don't know what the numbers are, I can't do the math. Like, I don't have to worry about addition, subtraction, any of that, because I don't know what these numbers are. It could be any number. So all I'm going to do is go through the steps to isolate for x, but I don't have any operations to perform. Are we all on the same page? So look at this, guys. If I'm solving for x, I'll do the same thing that I did over here, right? I want to get rid of the subtraction by adding to both sides. But this time, instead of adding a number, I'm adding a what? B. I'm just adding a B to both sides of the equation. Now listen to me. Stay with me. Okay, stay with me here, because I want you to remember our rule of combining like terms. Can we combine terms that are not alike? Yes or no? Unlike terms, we can combine them? No. But like terms, we can't. Well, if I move stuff down, okay, AX moves down, right? The B's, look at the B's. Those are the same, and I got a positive one and a negative, so that means those are going to cancel. Do we see that? Then it equals C and B, are those alike? No. No. So I am going to say that this is just C plus B. Does that make sense? Now look at that, Alex. Did you have to do operations like you had to over here, where we had to actually add 13 and 5? Did you have to do that? No, you did not. So this kind of is a little bit easier because we don't have to worry about messing up our negatives or making a mistake, right? These are literally literal. Now, if I want to get x by itself, I got an ax over here. What do I do to get x by itself? Well, look at the left. What we did is we divided both sides by 2, right? To get x by itself. Well, over here we do the same thing, but this time we're dividing by a what, guys? E-learners or face-to-facers? We're dividing both sides by what? E-learners or face-to-face? Yeah, not ax, just the a, okay? Just the a. So I'm going to divide both sides by that a, and then I got an answer for x, okay? I don't know what the value is, but I know for any number, x is going to be equal to c plus b divided by a. Are we all on the same page? Do we all understand what literal equations are? At the top of your paper where it says notes, I want you to write that literal equations are equations with multiple variables. Equations with multiple variables. So what I want you guys to do right now is I want you to find one similarity between the two equations we just did. And then I want you to find one difference, and I want you to write that down. One similarity and one difference. I'll give you a second to think about how were those two equations similar, and then how were they different. Both of them, both had inverse operations, right? Both used inverse operations. And that really just sums up what you all said. Now, what did you notice as a difference between the two? What's a difference? And e-learners, go ahead and type yours in the chat box, face-to-facers. Share with me, what did you notice? What was different? Here, one is all variables. The other one is all numbers. This is a difference. One is all numbers, right? All numbers except for one variable. Right? So it's easier to solve because we only have one variable. All right. So guys who are just joining us, we're going to do some one-step equations, and we'll practice solving the one-step equation. And we're realizing that these are not so bad as long as we know what we're solving for. If they don't tell us, then we're going to be confused because there's so many variables, right? Well, let's look at this. Number 1 says solve for W, which means I want to isolate W. Hey guys, they give us A equals L times W. What do we have to do to get W by itself? Divide by what? A. Is it A? What's being multiplied times the W? L, yeah. So what we're really dividing by is L. We got to divide by L to get W by itself, okay? So on the right side, the L's cancel, and we're left with A, and I'm going to do a little a over a big L so that way we can see the difference. AL equals W. Good job, guys. All right, let's look at number 2. It says solve for H. What do we do to get H by itself? We got A equals B times H. What do? We're dividing again, but this time we're dividing by what, e-learner? B. I'm dividing by B on both sides of the equation. On the right side, left side, I get A over B. And it equals H. All right, let's do one more together, and then I'm going to have you, no, let's do two more together. Two more together, and then I'll have you guys try this by yourself. 3, you're going to solve for T. Solve for T. What do I do to get T by itself? Well, I'm dividing again, right? I divide by R. So I end up with D over R equals T. Now I'll do this last one with you, and then I want you to try number 5. They tell me to solve for T. So I look and I'm going to divide, but this time when I divide, I notice there's 2 variables being multiplied times T. So I'm not going to divide just by R or just by P, but I'm going to divide by P and R, both of them. I got to divide by both of them, okay? So what I end up with is I over P and R equals T. Guys, take a second. I want you to try number 5 by yourself. If I look at number 5 and I want to solve for H, H has 2 variables, right? L and W. So I'm going to divide by L and W on both sides. And then I end up with, this all goes away, and I get V over LW equals H. Look at that. Now, guys, I want to move to the next problem. Okay, I want to move to the next problem because notice, guys, it says solve for R. And I think you guys know what the first step is. What are we going to do first? Divide. Divide out that pi, right? Let's divide out that pi symbol. So I'm going to divide both sides by pi. And I end up with A over pi. Now here's the part that I think you guys would probably get a little confused on. A over pi equals R squared. Okay? Do you guys see that? Now here's the issue. We got to get rid of the square. So in order to get rid of squares, guys, we take the square root. When we raise something to the second power, to get rid of it, we'll take the square root. So what I'm going to do is I'm going to square root both sides. I'll take the square root of both sides. Okay? And so I know that on the right side, the square root cancels, and I'm left with R equals the square root of A over pi. This is a big problem. That was a big problem. Hey guys, we're working on 7 and 8. When you're done with 7 and 8, e-learners, you'll type done in the chat, and face-to-face, or just look up at me. Try 7 and 8. For number 7, let's go over number 7. I need to solve for C. So my first step is going to be to add S to both sides of the equation, right? So I should end up with, remember we can't combine like terms, a M plus S equals C. For number 8, again, I'm trying to solve for M, if V is being divided by M, that means I'm going to multiply both sides by V. Okay, so I multiply both sides by V. Which means that to the left side, or the right side, my V's cancel. To the left side, I have V times D. So I'd have V times D equals M. How many of you got that? If you're an e-learner, type me in the chat. If you didn't get it, but you know how to do it, type me in the chat as well. Face-to-facers, how are you feeling on this? Let me know. Let me know, face-to-facers. Give me a thumbs up. Okay. Yeah, 8 is tricky. But now you know that's just division, so think your inverse operation, okay? Make sure you think about inverse operations. If I'm dividing by V, that means I need to multiply by V. All right? Good job, guys. Good job. Now, let's move on. I wrote down a couple of hints for solving these backwards when you have multiple steps. The first little step to think about is that you're going to think about PEMDAS but backwards, okay? So you're going to get rid of addition and subtraction first, then do inverse multiplication and addition and division, and then your exponents in parentheses. So work backwards. You want to remove fractions by multiplying by the reciprocal, okay? And the last step, you usually want to divide by whatever is next to your variable, all right? So with that being said, guys, let's look at 9 and we'll look at 10 together, and I'll have you do 11 and 12 by yourself. If I look at number 9, guys, it tells me to solve for H. So I'm going to think PEMDAS backwards, okay? I'm thinking that what's going to happen first is that because, and this fits my fraction, I'm going to get rid of this 1 over 2. And because I'm dividing by 2, I'm going to do the inverse of that. I'll multiply both sides by 2. Right? Let's get rid of that first, that 1/2. I'm sorry. Let's get rid of that 1/2. Which means to the left side, I'll have a 2a. To the right side, I start getting rid of the things beside the h. Okay? So to the right side, that 1/2 cancels, and I'm just left with a b h. I don't have to write the 1 here because it's just 1, right? We know that's a 1. The next thing I want to do, guys, is get rid of the b, so h can be by itself. So I'm going to divide both sides by b. And now I've solved for h. Right? The b's cancel. I end up with a h equaling 2a divided by b. 2a over b. These are literally literal. Number 2, guys, it says solve for b. Again, let's get rid of our fraction. B is over here. B is being multiplied by a 1/3. So, guys, let's do the inverse of that. Let's go ahead and multiply both sides by the denominator 3. Does everybody see that? Does that make sense, guys? Tell me face-to-facers. Is that making sense? Okay, we want to get rid of the fraction by multiplying by the denominator. All right, so when I do that, guys, to the right, the 3's cancel, and I'm just left with a BH. To the left, I have a 3 times V. Now again, to get rid of H, because I got to solve for B, I've noticed that H is being multiplied by B. So that means I'm going to divide both sides by H. All right? And once I divide both sides by H, I realize that B is just equal to 3V divided by h. How are you feeling about that, guys? We got, okay, now I want you guys to try 11 and 12. Okay,